All right, today we're looking at the second FRQ from our AP review. We're going to be working on this problem right here. Remember, this is the answers and the point distribution, which means you should be watching this video after you've already worked the problem, not before. So if you have not finished the problem and completed it, you need to stop and go and work it first. When you turn it in, I want you to turn it in just like any other video or homework I ask you to turn in involving free response questions. Make sure you score yours as if you were being as critical as possible, and make sure you have the points shown on it when you turn it in. Okay, so let's start with this problem. We have a differential equation, dy over dx equals y squared times 2x plus 2. Saying y is equal to f of x, be the particular solution to the differential equation, and f of 0 equals -1. So, because this is a differential equation, we should automatically be thinking, oh, I may have to solve for the solution to this differential equation later. Don't have to do it yet, but maybe something we need to do. So let's start by looking at A. Right, find the limit as x approaches 0 of f of x plus 1 over sine of x. So limit as x approaches 0 of f of x plus 1 over sine of x. Okay, let's start by just looking what happens when we plug these in. Well, f of 0 plus 1, they tell us f of 0 is -1, so that means this equals 0. Sine of 0 is 0. So, since the numerator and denominator are 0, we can use L'Hopital's rule. So this is the limit as x approaches 0 of, well, the derivative of the top would be f prime of x over the derivative of the bottom, which is cosine of x. Now we just plug in 0, so f prime of 0 over cosine of 0. And that gives us f prime of 0 is what we get when we plug in 0 here. Now, 0 is our x, but we also have y in there. Well, we should remember that y, when x is 0, is -1. So this is -1 squared times 0 times 2 plus 2 over cosine of 0, which is 1. -1 squared is 1. 0 times 2, that's 0, so 2. So we end up with 2 over 1, not 2 over 2, 2 over 1, or just 2. So this is part A. Let's look at the points for part A. We have only 2 points available for part A. 1 for doing all of the L'Hopital's rule part correctly. So identifying that it's 0 over 0 without saying it's 0 over 0, applying L'Hopital's rule properly and getting the correct equation for L'Hopital's rule, and then 1 point for your ending up with the correct answer. Okay? So there is our part A. Part B. We're using Euler's method, starting with x equals 0 with 2 steps of equal size to approximate 1/2. So let's think about what our x's are. If our first x is 0, and we want our last x to be 1/2, and we want our steps to be equal side, then we need, well, we only want 2 steps and we want them to be equal sides, then we need to cut this directly in half. So we're going to say our x in the middle is going to be 1/4. Okay, so we have, x naught is 1/4, or sorry, let me rewrite that. I can get this to erase. We'll just do it this way. So we have x naught is 0, x1 is 1/4, x2 is 1/2. Now let's look at our y's. We know y1 is equal to -1. y2, or sorry, not y1. Man, cannot talk today. We know y0 is equal to -1. And because we're doing Euler's method, we know y1 is equal to y0 plus dy over dx at x naught comma y naught times delta x. All right, well, y0 is -1. dy over dx at x naught comma y naught, well, let's see what that is. So plug in x naught, which is 0, plug in y naught, which is negative 1, so that is negative 1 squared times 2, and that gives us our y2. Well, y2 will then end up being 1. Or sorry, not y2, y1. Then we can find y2 by doing the same thing, just moving everything up a little bit. So y2 will be y1 plus dy over dx at x1 comma y1 times delta x. Oh, that's the one thing I missed. I missed times delta x there. Look at me. Our change in x is 1/4. So that's going to actually change this a little bit. So it's 1/4 times 2, which is 1/2. Then plus negative 1, which gives us negative 1/2. My bad, guys. So, yeah. All right, so now that changes what our y1 is. y1 is now negative 1/2 plus, then we do the derivative at x1 comma y1. So that's 1/4 for x, negative 1/2 for y. So negative 1/2 squared times 2 times 1/4 plus 2. And then times delta x, so times another 1/4. And when we plug this in, we end up getting negative 11 over 32. So let's look at the points here. You get 1 point for doing Euler's method appropriately. So all of this stuff right here, done correctly, that's 1 point. And then 1 point for your correct answer of negative 11 over 32. Okay? Now, if you've been keeping track of the points so far, that means we've done 2 problems, but only done 4 points. Now, you should know by now that normal AP problems have 9 points total. That means this last part is going to be 5 points. Okay, so 5 points here. So 2 points, 2 points, and then 5 points here for this last one. All right, so now this is the part we knew was coming. Find the particular solution. So dy over dx equals y squared times 2x plus 2. But I know you guys are good at solving differential equations. So let's solve it. We'll separate the variables. So 1 over y squared dy equals 2x plus 2 dx. We'll integrate. So negative 1 over y equals just x squared plus 2x plus c. Now, here's where some people differ. Me personally, I will solve for c here, because I can look at this problem and see, oh, this is eventually going to turn into a fraction, 1 over everything under there, and that's going to be really ugly. So I'm going to solve for c here. I'm going to plug in our c finder of 0 and negative 1. So negative 1 over negative 1 equals 0 squared plus 2 times 0 plus c. Well, that leaves c to just equal 1. And now we can plug that in and solve. So we have negative 1 over y equals x squared plus 2x plus 1. We can flip this and divide by the negative 1, so we end up with y equals negative 1 over x squared plus 2x plus 1. And there we have it. There's our answer. So let's look at how this would actually be solved. Oops. Let's make sure we write our integral symbols there. Let's look at how this would actually be solved, or how it would be scored, not solved. So you get 1 point for the separation of variables. So 1 point just for going from here to here. Okay? 1 point for the correct antiderivative. So 1 point going from here to here. 1 point for remembering to do plus c. All right, so 1 point there, 1 point there, 1 point there. 1 point for solving for c using the correct values. So this whole part right here, 1 point. And 1 point for solving it in terms of y. Okay, so 1 point there. And this would have been your 5 points for this problem. Okay? All right, remember you can come to tutorials to ask any questions. Let me know if anything else comes up. Make sure you score your own problem, take a picture of it, let me know, and submit it for homework. You'll have a great day.